All right, hello everyone. I hope everyone is doing well and staying safe. Mina and I just wanted to do a quick video to review the three different types of copying. We'll go through some examples, and then if you guys have any questions, you can put those up on Piazza for us. All right, let's get started. So in this first example, I'm creating a data structure X. This is a list, and inside the list I've got three dictionaries. Each of the dictionaries is tracking the scores for one player. So I've got Alice, Bob, and Carl, and their scores 88, 111, and 100. Now I'm going to pop over to Python Tutor in just a moment and run through these, but just a quick overview as we get started. I'm going to create a copy using the three different techniques, creating variable y. The first one is just creating a reference. So in this case, y is going to reference the exact same object that x does. This is very fast. It just needs to copy the memory location, but it's also a little bit dangerous because if we change y, it will also change x. I'm going to jump down. The third one is probably the most intuitive and what we'd expect from copy. That's deep copy. It's going to make an exact copy of everything. So it's going to create a brand new list, y, and inside the list it's going to create three brand new dictionaries. One for Alice, one for Bob, and one for Carl. The second one, copy.copy, really should be called shallow copy. This is only going to copy the very first level of reference. And then inside of that, it'll create one new list, and it'll have three references to dictionaries, one for Alice, Bob, and Carl, but they will be the same dictionaries referenced through the X variable. Okay, let me pop over to Python Tutor and take a look at these. Okay, so I did the PowerPoint version of this during my lecture, and so I want to do the Python Tutor version so we can actually take a look at what's going on inside Python's memory module. All right, so first I've created my variable x. I've got my data structure over here. So this is a list, and inside the list we have references to three different dictionaries, Alice, Bob, and Carl. All right, let's uncomment the first one of these, and then we'll run it. We see over here we get another variable in the global frame y, and this is a reference to the very same list that x points to. So x is a reference to a list, y is a reference to the very same list. This means that if I make any changes to either object through either x or y, it's going to affect both of them. Okay, I'm going to put this back, take a look at the second example. Now when this code is run, I'm creating a brand new variable y over in the global frame, but this is now pointing to a separate list. We've made a copy of the x list and put the data into the y list, but it's copying the references. So in the x list, element 0 refers to the Alice dictionary, and in the y variable, the 0 element also refers to the very same Alice dictionary. So this means that if I make a change to this list, it's not going to affect any of the data stored in x, but if I use y to access these dictionaries and make a change, because the x list also is referencing these very same dictionaries, it's also going to change the x data. So that's shallow copy. It only follows the very first arrow, just one level. Okay, finally deep copy. Let me zoom in a little bit so we can see the full thing. Deep copy works just like we would typically expect a copy to work. It's going to make an exact copy of all of the data and all of the levels. So up here we have x. I've copied the list, and I've created new dictionaries for Alice, Bob, and Carl. Okay, so let's take a look. I'm going to pop back over to PowerPoint. Pull up my next slide. Some motivation for when we might choose each of these different types of copying. So in my three examples, I'm going to do them in Python Tutor. I did them in PowerPoint during lecture. So we'll get a little bit different perspective if you were there for lecture. So for use case number 1, if I want to just find the maximum score, if I'm not actually going to make any changes to the data, when I pass this to a function, it'll make a reference copy. I don't need to do anything more complicated because I'm not changing anything. In use case number 2, motivation for using shallow copy, what I want to do here is sort the data based on their score and then select the middle value. So in this case, we'll get Carl after we sort it as the median score holder with a score of 100. But I don't actually want to change any of the dictionaries. So a shallow copy will just give me that first level, and I won't be changing any of the scores in the dictionaries. So it's a good use for a shallow copy in this case. And then in use case number 3, I'm going to be taking a look at their halftime scores, 88, 111, and 100. They're going to score some more points. I'm going to record this final scores at the end of the game, and then we'll see how many points they scored during the second half. But in order to retain all of that data, I need the deep copy to get all of the values. Okay, I'm going to pop back over to Python Tutor and take a look at the second example, or the very first example of a use case, getting the maximum score. So just to walk through code that takes care of solving this problem, I'm going to import the copy module and just make a note of where that's stored in my global frame. I've got my player data structure. So this is the same list I've been using for all of my examples. Players is a reference to a list that has 3 dictionaries. I'm going to define a function that computes the maximum score. So when I click next here, that'll be added to the global frame, and it just is going to take note of where that function is stored. And then when I run the function, max scores, right here I'm creating a brand new parameter people. It's a variable inside the frame for max score, and this is going to be just a reference to that very same list from players. I don't need to change anything, so there's no need to do anything more complicated than this. Alright, and then just standard code for finding the maximum. I'm going to set highest equal to none, and then I'm going to iterate through all of the people. So first P in people. If highest is equal to none, then I'm just going to assign highest the score that P gets. So highest will get the score for Alice, 88. As we walk through this, so highest will be 88 right there. Then we're going to continue on and iterate through the rest of the people. So P will then point to Bob. I'm going to compare Bob's score to highest and find that it's better. And now I'll record 111 in highest. Then finally, P will refer to Carl. I'll go through and compare score 100 to highest. 100 is still the best, so I skip reassigning highest. And then I'm going to return 111. Return value. And when I'm done with the function, I store it in M. The frame for that function is deleted. It's destroyed, gone forever. Alright, so this is an example where we wanted to just make a reference copy. We didn't need to do anything more complicated because we didn't change any of the data. Okay, in the second example, I'm going to be computing the median score. So I've already walked through the first couple steps of this, importing the copy module. I've defined 2 functions here. Median score is the important one that I'm going to use to actually sort the data and extract the median value. In my sorting, I want to sort by the score. So I have a special function here that's going to allow us to use the score value to sort the data in these dictionaries. And then I've got my data structure, players. Same thing I've been using the whole time. Okay, and I'm right on the line here. Red arrow is what executes next. About to call the median score. So let me walk through this from the next step. So we jump into median score. First people here is going to reference the very same list that players is. It's a parameter. But I want to be able to sort this without changing my players. Right now they're in alphabetical order. I want players to stay that way. I don't want to mess that up. But I need a sorted copy, sorted by scores, in order to find the median score. So I'm going to make a copy of these people. So I'm going to use copy.copy on people and store that in a variable copy of people right there. So let me do that next. There we go. I've got a copy of people. And now I've made an exact copy of this list. But all of the values still point to the same dictionaries. I don't need to do any more work because I'm not going to change these. Okay, the next thing I'm going to do is call the sort function with my sort by score key. As I step through this, it's going to take a couple of steps. It's going to call sort by score several times. So we jump down to the first sort by score. P is now pointed to Alice. It's going to grab her score of 88 and return that. Return value 88. And it's going to next go through and grab Bob's value. It's going to compare Alice to Bob and decide who has the better score. Then we're going to grab Carl's data. Excuse me. Compare Carl. And then when we get to this point, we now have the copy of people has these references pointed to things in a different order. So reference 0 is still pointed to Alice. She has the lowest score, 88. In position 1 of the list, I have Carl. He's got the second highest score with 100. And finally, in the second position 2, I've got Bob with the highest score. Excuse me. Finally, I'm going to return I'm going to extract the median value, the score 100 from Carl, and return that. So now M has 100. And when I exit the median score function, that frame also is terminated. And for the third example, computing the scores, the number of points scored during the second half, I've imported copy, I've got my data, just like before. And now I'm going to make, at the red arrow, copy, not just a copy, but a deep copy of all of the data. Let me zoom in. So we've got an exact duplicate of all of the data as of the scores of the first half. And then Alice has a really spectacular second half. She scores 64 more points and now has a score of 152. I'm going to compute the change. Note that Alice's score from the first half, my copy of that data did not change, still at 88. So I'm just going to compute the change and then print that out. So change is 64, we'll print that out. Alice scored 64 points during the second half. Okay, so if you guys have any questions about the three different types of copy, go ahead and post those on Piazza. And I hope everybody is staying safe and enjoying the rest of the course by video. Anyway, if you have any feedback for me, this is my first ever YouTube video. Go ahead and post the feedback on our feedback form on the webpage. If the video is of low quality or the sound is can't hear it, let me know and I'll see what I can do to fix those issues. All right, have a great day.